Hi, we're going to take a look at solving two-dimensional conservation of momentum questions for Physics 30. So let's start with this question here, and you can use a highlighter or something like that so that you can organize what it is that you need to find. So first of all, you know that there's a 10 kilogram ball and it's moving at 6 meters per second, but then there's also a stationary 7 kilogram ball. Then it says after the collision, the 10 kilogram ball travels at a velocity of 3.5 at 20 degrees south of east. And we want to determine the velocity of the 7 kilogram ball. So what we want to do is just organize our work a little bit. So as we did in class, let's determine the initial setup. So let's draw ball number 1 moving at a velocity of 6 meters per second. And ball number 2 is simply stationary. Then let's set up our final conditions. And we'll have ball number 1, which is the 10 kilogram ball, moving at a velocity of 20 degrees, but at a velocity, I'll put prime because it's after, at 3.5 meters per second. Ball 2 then, the one that was stationary, must be moving up at a velocity in that northeast quadrant. This is the velocity that we want to find. So once we've established a diagram, we can take a look at labeling our component vectors to organize our work. So I'll call that one v2x prime and v2y prime. This one is v1x prime and v1y prime. And then I can head into the work. So using what we have, there are two separate balls to start with, and that means we have two separate terms in our equation. And after the collision, we have two separate masses, so we have two separate terms in our equation. We have to set it up for x individually from y, or independently from y. There's m1 v1 plus m2 v2 equals m1 v1 prime and m2 v2 prime. Now you can record x here if you like to show that it's the x-axis. Now we also see that ball 2 is stationary, so it doesn't have an x velocity, but the other terms stay. And we know that we want to find ultimately the velocity of ball 2 after the collision, so we need its x component here. So let's rearrange our equation for this x component. So mass 1, velocity 1, x minus, I'll get rid of that, minus mass 1 v1 x prime, and then divide that all by mass 2. Now we can substitute into the equation. So mass 1 is the 10 kilogram ball, so 10.0 kilograms. So let's write that in. Moving at a velocity of 6 meters per second in the positive direction. And we also have mass 1 here, and its velocity is 3.5 meters per second, but at 20 degrees. So we want to say negative 3.5 meters per second times cosine 20 degrees. So we want negative in there because this, well, actually in this case, this will be positive because it's the x component. We'll put negative for the y component. So then we'll divide by mass 2, which was a 7 kilogram ball. So let's put 7 kilograms. Okay, let's solve for the x component of velocity 2 after the collision. So using our calculator, 10 times 6 minus 10 times 3.5 times cosine 20, and then press enter or put this in brackets, and then divide by 7. So we have a positive velocity Okay, here we go. Positive velocity of 3.9 with 2 significant digits meters per second. Now we'll switch this up to the y-axis, and we'll start again with mass 1, mass 2, and that's equal to mass 1 v1y prime and mass 2 v2y prime. Now we know mass 2 was not moving, so it has 0 velocity in the y-axis. And mass 1 was only moving, as we can see in our diagram, only moving to the right. So it does not have a y component either. And we want to find this y component of the second mass after the collision so that we can put it together with the x component and find the overall velocity. So let's rearrange this equation. And then we'll substitute into the equation. Mass 1 was 10 kilograms, and its velocity after the collision. So we need its velocity, which I'll go back up here. It's 3.5 meters per second at 20 degrees. So we will put 3.5 meters per second at 20 degrees, but we want the y-axis, so this is sine of 20 degrees. Now this is where we have to put the negative because this component is downward. And then we'll divide by the mass of the second ball. Okay, let's put this in our calculators now. This should be a positive velocity upward. And we'll say 10 times 3.5 times sine of 20 and divide it by 7. So 1.7 meters per second. Now let's put these two together. We've got the 1.7 meters per second for the y-axis for the second ball after the collision, and 3.9 meters per second for the x-axis for the second ball after the collision. So we can solve for these using Pythagorean theorem. So we want to find the velocity of the second ball after the collision. So we'll take v2x prime all squared plus v2y prime all squared and square root. So substituting in here, we have 3.9 meters per second all squared and 1.7 meters per second all squared, square root. So we'll use our calculator here, 3.9 squared plus 1.7 squared, and square root of our answer. And I get 4.25, so 4.3 meters per second. And then I'll calculate the angle. So I know the relationship is tangent, and the opposite side to that angle, if we look up here for V2, the opposite side is V2y prime. So that's going to be divided by V2y prime is going to be divided by V2x prime. So tangent negative 1 of 1.7 divided by 3.9. And so this wraps up our question. Shift 10, 1.7 divided by 3.9. and this is 20